Hello, everyone, and welcome to the first coding tutorial of the 2023 season slash year, I guess, depending on how you want to view it. For those of you who don't know, my name is Arjun Menon. I am currently a senior at the University of Michigan. I'm also the current president of the Michigan Football Analytics Society, the best sports analytics club in the United States, as we proudly like to say. But we're here. We're going to be doing some coding, some live coding. And this is going to be a continuation of the tutorials that my predecessor, my former president, Tage Seth, has done. So this is going to be kind of like an intermediate type coding tutorial. What we're going to do today is we're going to be looking at player run pass tendencies using free public NFL data from NFL FastStar / NFL Radar. Thanks to the new data that the NFL Radar team has put together over the past year. There are so many different things that we can do with it, including scouting opponent teams, scouting opposing players. And that is one of the things I enjoy. And I wanted to put together a tutorial that would allow people to do the same thing that I can do, but show you how to do it in a live manner, but also make this code publicly available. So the first thing, though, I do want to talk about, if you haven't, coded before and you're trying to just start with R, I wouldn't recommend this tutorial. I would go to the MFANS YouTube page. So literally just search in MFANS and NFL data, and you'll probably see the YouTube page. This tutorial is going to be in R, so I would first recommend watching this introduction to NFL data with R from last year. This was, again, my former president, Tage Seth. This was his video. Does a tremendous job explaining how to use R, how to use NFL data in R. It's a great tutorial. And then, you can go through the other tutorials. In terms of this tutorial, I think its difficulty falls between data viz and making models, because we're not making any models in this video. We're really just learning how to manipulate data, how to summarize data in a way that it's easy to see the output. And we're trying, we are looking at player run pass tendencies. So it's not like we're creating models. We're just doing a lot of data summary and cleaning. And as usual, like Tage did last year, I will make all of this code that I write up in this video available. If you go to my GitHub at ArjunMenon10, look up MFANS coding tutorials, you'll see it's this player run pass tutorial. It'll probably take us about 140 lines. I'm not sure how long the video is going to be. It's my first time doing something like this, so please bear with me. But yeah, you can find all of this here on my GitHub. And again, if you are new to R, I would go to our MFANS YouTube page and watch these tutorials first. But we are here for the coding, so let's get into it. So again, we are going to be coding in R. So the first things we are going to want to do is, if you have never used NFL data, we are going to need to install some packages. So we're going to use the install.packages function, and we're going to install a couple different libraries that we're going to need to use to be able to do the work that is necessary. So the first couple, NFL Radar, that is the place where we pull all the data from. Tidyverse is a library that basically allows us to do a bunch of data manipulation and summarizing. And then GT and GT extras are two special kind of libraries that you can use for making tables. Because I already have all of these installed, I don't need to run it. Instead, since I'm using a new R window, I'm going to need to read these into my library. So I'm running library NFL Radar, library Tidyverse, library GT, and then library GT extras. So once you have these 8 lines of code run, what we can first do is we are going to load in the public participation data from NFL Radar. So I am reading this into a data frame called PBP, which essentially stands for play-by-play. I'm using the load participation function that comes from the NFL Radar library. Another way you could write this is NFL Radar. The two colons kind of signify like what function you want to call. So you can see once you have the 2 colons, you can see all the functions you can call from the NFL Radar library. So we are using the load participation function where we want to call 2023 data, and we want to include all the columns from the play-by-play data set. So once we load that, the first thing we're going to want to do is just look at what type of data we have to work with, right? So when we run this names PBP line of code, you can see in the console down here, there are 383 columns that we have to work with. Now, are we going to use all 383 columns? No. And so it's important to kind of find out like what is necessary for us to work with, to find out how are we going to look at player run pass tendencies. So, this is a lot. Another way you could do this is opening. You click on the data frame in the data in the environment section, and you can see every single row of data plus every single column, 50 columns at a time. So the main column we're going to need to use is this offensive player. So you can see the offensive players, it gives us the player IDs for every single player on the field on a given play, separated by semicolons. So now, this is a very tough column to work with because it's really tough to do any type of analysis with this alone. So the first thing we're going to need to do is adjust the play-by-play data frame so that every single player has its own row, because otherwise we're not going to be able to do any analysis, or it would be very tough to do analysis with it. So what we're going to do is we're going to use the separate rows function from the tidyr library, which you get from reading in tidyverse. So we want to separate the offensive players row. And what do we want to separate it by? We want to separate it based on the semicolon. So similar to Excel, Excel has that text to columns feature, right? And you can say, I want to separate text to columns based on a comma or a colon or semicolon. That's essentially what the separate rows function is doing here. Essentially, and also what we want to do, we want to look at specific columns that are necessary. Like we don't want to have to open the play-by-play data frame and look at every single column on every play. We want to narrow down what columns we need. So I've already kind of done some of this work for you guys, and so you guys can just copy along and follow. But we are going to look at the game ID, the play ID, the offense, which is the post team, def team, which is the defense, week, and then obviously we need the offensive players column. We also are going to look at offensive personnel, which I don't think we'll necessarily use in this video, but in future videos, this could be helpful. So, and if you guys want to play around with it on your own, that's why I included it as well. We want to look at the rush and pass column, which essentially tells us, was it a run or was it a pass? Win probability, which is important for filtering out garbage time. Down and yards to go. Yards to go is basically distance. Yard line 100, which is basically where the offense is on the field. And then the last two, which are score differential and pass OE, which stands for pass over expected. So again, this is what the data frame looks like before. You can see the offense players column, every single player is in one row. But now once we run this code, okay, what happened there? Oh, sorry, I should have mentioned step equals. So we want to separate the offensive players column by a semicolon. So once we run that, we can see the amount of observations our play-by-play data frame goes to is 295,000. And so now when we open it, we can see the offensive players column becomes one column, but every single player on every single play has its own row, which is what we want. So this is good. But as you can see here, there are certain columns where, okay, there's no offensive personnel, there's no offensive formation, rush and pass are 0, which means it's not a run play, it's not a pass play, it's a special teams play. And because for the purpose of this, we want to be as accurate as possible, we only want to look at offensive plays. We don't want to look at special teams plays. So what we're going to do is we're going to take the play-by-play data frame and we're going to filter it so that rush equals 1, or which is this this line right here, that's the or function, pass equals 1. So what this is saying is, you can see it shrinks down to 235,000 rows. Now every single play in this data frame is either a run or pass. So now we're actually looking at offensive plays. The next part, I'm just going to copy from my code on GitHub because I don't feel like writing the entire thing. And honestly, we don't even really need it. But this is basically just a simple case when function I wrote to determine down and distance. And you can change the way you do down and distances based on your own definition. So like, I know personally from my work in the past, people would like to differentiate 2nd and 1 and 2nd and 2. People like to differentiate 3rd and 1 and 3rd and 2 because offenses call different plays based on 3rd and 1 versus 3rd and 2. That extra yard means a lot. You could also group it in, and there's certain, you can just follow the guidelines for grouping, like binning 3rd and 3 through 6. You would just do that for 3rd and 1 through 2. But this is how I did it. So yeah, you can pause the video if you want to copy all this down. It's not necessary for this video as well, but just something that I put together that I think you guys could look at. Okay. Now, next thing we're going to do is we're going to just do a very simple query. We're going to look at the play-by-play data frame. We've already filtered to rush or passing plays. So the first thing we're going to do is filter out garbage time, because garbage time in football, that definitely plays or has a big part in determining rush and pass rates, right? Because when teams are losing, they're going to be passing the ball, and when teams are winning by a lot, they're going to be running the ball. So we want to filter out plays that, teams are in those obvious passing or rushing situations. So the first thing we're going to do is we're going to look at win probability. That is when the offense, it has a greater than a 2.5% win probability and less than a 97.5 win probability. I also just remembered, I totally forgot to include this line of code. So let's do this real quick. So sorry about but if you could go above the code we just wrote, we're going to load in the rosters for every single team, or basically every single player in the league with the rosters. We're going to name the data frame rosters and use the load rosters function and load in 2023 rosters. The next thing we're going to do, we're going to take our play-by-play data frame and we're going to do a left join with the play-by-play data frame and the rosters data frame we just loaded. And from the rosters data frame we just loaded, you can click on here to see all the type of things we have. But we are going to take three specific columns. We're going to take the GSIS ID, because the GSIS ID, you can see it has a 0, at the front, and that lines up with the offense players column in the play-by-play data frame. So we're going to take, so we're going to do a select GSIS ID, the full name of the player and the position. I'll tell you why we're going to do this. And also to join, we're going to do by equals C, offense players equals GSS ID. So what this is doing is basically, sorry, I forgot a T here. We're basically taking the play-by-play data frame, which is the left data frame, and then we're joining it with the rosters data frame, which is the right data frame, and we're basically saying the offense players column equals the GSS ID column. So now when we open the play-by-play data frame, we can see we have the full name for every single player on the field on a play, which is good, because when we were putting together the table at the end, we're going to need that full name there. So going back to what we're writing, so we're just going to do a very simple query. We want to look at non-garbage time, and we only want to look at positions that matter, positions that actually have a tell if they're on the field or not, which are running backs, which, the NFL data set calls them halfbacks, unfortunately, receivers, tight ends, and fullbacks. So if we just run this really quick, you can see, or I guess you can't really see much, so I guess we'll just skip that. But we're going to group by full name. So the group by function basically says what is the variable we want to look at specifically and what are we trying to do with it. And then we're going to use the summarize function, which is from the tidyverse pack or DPYLR package. And we're going to just do two simple things. We're going to look at pass rate is equal to the mean pass. So we're looking at the average pass column. We're going to look, what is going on? Sorry, guys. So pass rate, we're also going to look at the number of plays a player has played on the field at a given time, just because we're going to want to eliminate players with small samples. And also we're going to do PROE, which stands for pass rate over expected, which is the mean pass over expected column. And then what we're going to do, we want to look at the best, or we want to look at players that actually have tendencies. So we're going to filter to where the pass rate is either above 80% or the pass rate is below 20%, which basically says, so this part is saying it's, does a player have a pass rate over 80%? What does that mean? If they're on the field, it's most likely a pass, or it's been a pass over 80% of the time. This is saying when the player's on the field, the offense is passed less than 20% of the time, which is the run tell. Additionally, we're going to separate that with a comma, and we're going to only look at players who've had 50 plays or 50 snaps on the field. And then we're going to arrange it by pass rate. And we to arrange from ascending or from top to bottom, you have to put the negative sign in front of whatever variable you want to look at it from. So when we run this, this is what we see. We see 5 players who have played 50 snaps and actually have a run pass tell. So Kyle Phillips, when he's on the field, the tight ends have passed 90.1% of the time on 101 plays. When Tanner Hudson, who is the tight end for the Cincinnati Bengals, when he's on the field, the Bengals have passed 88.4% of the time on 95 plays. When Deontay Hardy is on the field on 115 plays, the Bills have passed 80.9% of the time. And again, we included the pass rate over expected column because we wanted to contextualize this even further. When is Kyle Phillips on the field? He's most likely on the field on third down, right? So the expectation for a pass is high on third down. And so that's why even though he has the highest pass rate, his pass rate over expected is kind of closer to 0 than any other player here, right? Versus Tanner Hudson, he has a pretty high pass rate when he's on the field, but if you look at his pass rate over expected, it is pretty high. The Bengals pass 16.1% of the time more than expected when he's on the field, which means he's probably on the field on early downs where the expectation for a pass is much less. So, and the only player who has a run tell, basically like when they're on the field, we can expect the Ravens to run the ball, is Charlie Kolar. The Ravens have run the ball 80% of the time when he's on the field, and they have a negative 27.5 pass rate over expected. So they pass the ball 27.5% less than expected when he's on the field. Okay, so this is a very simple query. Like, we've accomplished a run pass tendency thing. We've filtered out garbage time. We're only looking at positions that really have a tell. Is this something that we could present to Sean Desai for the Eagles that he can use? Maybe not, right? Again, the problem with this kind of overarching data, or like this general tendency look, is we need to contextualize things a little bit more, right? Kyle Phillips, if he's on the field on third down, yeah, like, it's most defensive coordinators don't need you to tell them, if this player's on the field on third down, it's going to be a pass. Like, third downs are generally passes unless it's like 3rd and 1 and you're the Eagles, right? So what can we do with the data to contextualize it and add more context so that it makes a lot more sense? So the next thing we're going to do is we're going to basically just copy this code. I would recommend writing it again for muscle memory, but for the sake of time for this video, we're going to copy the code. And inside this group by function, we're going to add down. And what we're also going to do is we're going to shrink the sample size to 20 because we're subsetting this entire data by down now. And we also only want to look at first and second down. So the way you look at multiple different variables within a data frame is you use this percent in percent function or symbol, I guess, C1 and 2. And now let's see what we're looking at. Now you can see there's a lot more, right? There's a lot more things that we can look at. So these are a list of players who are on the field, basically on first and second down. And when they're on the field, there's a very high pass rate. So again, Kyle Phillips still shows up super high here. So maybe, him being on the field is a big tell. We are filtering out garbage time. So it's not like, these are only plays where the tight ends are losing by like 14 in the fourth quarter, right? And you can adjust the garbage time filters if you want to look at like 5% to 95%. You can. It does change things a little bit, but I do tend to like using a little bit wider garbage time filters because I do think more data is always helpful in a small sample size sport like football. So again, you can see here we have the player, we have the down, we have the team's pass rate when they're on the field on that down, we have the number of plays just so we know what the sample size is, and we have the pass rate over expected, which is contextualizing everything in one singular metric based on the expectation of a pass. So another thing you could do if you want to make this type of output look cleaner, between full name and down, you can also group by position, which basically just says like what position are they playing. I think it depends how you want to view it. I think later in the tutorial that might come in handy, but at least for now, you can see this is what it looks like. So I'll pause real quick so that people can catch up. But this is what this outcome should look like right now. Okay, so let's keep going. Now, one of my favorite things to do again is to look at this from a team's perspective, right? What is one team that drafted a player that everyone thought it was for a certain reason, and early in the season we gave a hypothesis that when this player's on the field, it's most likely going to be a pass. To me, that was the Buffalo Bills with the drafting of Dalton Kincaid. So we are going to look at things from the Buffalo Bills perspective. So we're going to take the play-by-play data frame. We're going to filter it. So the offense slash post team is what it's called in the data frame. It equals Buffalo, BUF, and you have to put that inside an apostrophe or quotation marks. We're going to do the same win probability filters. Win probability is greater than 2.5% and less than 97.5%. And we are going to group by play ID, because what we need to do here is isolate Dalton Kincaid. But also I want to look at Dawson Knox as well, because he's also a tight end and he also has some similar tendencies. So what we're going to do first is we're going to create two new variables. The first variable is going to be called Knox in. Basically, is Dawson Knox in the game on this play? Because we're grouping by play ID. So we're scanning through every single row with the same play ID. And what we're going to do is we're going to use this any function. So we're going to say anytime the full name for a player, right, which is this column here, if any row inside a certain play ID has Dawson Knox, that row is going to be true. And we're going to do the same thing for Dalton Kincaid. So any full name equals Dalton Kincaid. And then we're going to use the view, we're going to use the pipe function view so that it shows up here, right? And so let's see what we get. So this is saying Dawson Knox is in on this certain play ID. So the play ID stops right here on row 11. So we want to look, is Dawson Knox in this full name thing from row 11 up? And yes, we can see him right here. Is Dalton Kincaid in? Because this is saying Dalton Kincaid is in on this 1st and 10 play. And yes, we can see him right here. So the code worked. So again, what this any function is doing is it looks at every single unique play ID and it's saying whether or not our statement is true or false. We're seeing if any row in this play ID 58 has something that says Dawson Knox is a full name or Dalton Kincaid is a full name. And if that's the case, it shows up as true. And if that isn't the case, it'll show up as false. So you can see here in these rows, there's no Dalton Kincaid in the full name column, so it shows up as false. Okay, so let's delete that view function call, and we're going to group by Knox in, Kincaid in, and you can honestly just copy this summarize function because we're basically going to look at the same thing from above. And this should be Kincaid in. Okay. Boom. Oh, wait, no, sorry. One more thing. When you after the mutate function, put this slice 1. I'm actually going to show you what it does. So initially, when we ran just all this together, right, we can see it looked at every single row, right? But because this is true for every row with the same play ID, we don't need every single row of data, because that, you can see here, that messes up the number of plays. We only want to look at one row within that play. So what we're going to do is we're going to use the slice function, which basically takes one row from each play ID. So we've already established whether they're in or not. Now, because we've established that for every single row, we just need to look at one row. So we're using the slice function, and then we're going to group by Knox in, Kincaid in, and this is what we get. And these numbers make a lot more sense. So you can see here, when Dawson Knox is not in the game and Dalton Kincaid is not in the game, the Bills pass the ball 46% of the time. When Knox is out and Kincaid is in, they pass 75% of the time with a 9.7 pass rate over expected. When Dawson Knox is in and Kincaid is out, The Bills pass 63% of the time with a 1.06 pass rate over expected. And when both tight ends are in, they pass about 68% of the time. Okay, that was a lot of information. What does this mean? How is this important? Well, we can start off with the basic. We just look at this basic table, and we can see when Dalton Kincaid is in, that is when the Bills have had their highest pass rate in terms of these tight end groupings. Now, Dawson Knox has also missed the last couple of games. I'm recording this on November 21st, so we are entering week 12. So he's, I think, missed 4 games in a row at this point. But the Bills pass the ball the most when Dalton Kincaid is in the game. And when he's out of the game, that's when they've had their 2 lowest pass rates. And when both of these athletic tight ends are out, they run the ball more than they pass the ball on 56 plays. And again, we are filtering out garbage time. So when they do, run their 11 personnel sets or even 12 personnel sets without either of these 2 tight ends, and they bring in Quentin Morris and I guess James Gilliam is their fullback, if I'm not mistaken, that is when they run the ball a lot more. And you can see they have a negative 7.7 pass rate over expected. So now, again, this code can be used for any single team in the league, right? Like this, you can use this code for any team, any player you want. So just to, this is not in the, it's not in the code itself, but say we want to look at another team. Let's do Atlanta, because I think Atlanta is a fun team, right? You talk about Kyle Pitts. So let's just rename everything. So, Pitts in, and then we're going to do Smith in, who stands for Johnny Smith. And we're going to look at the same thing, and we're going to adjust the group by to fit that. So again, we're looking at Atlanta. We're filtering only plays where Atlanta's offense, non-garbage time, and running the same functions. And let's see what we get. So, wow. So when both tight ends are in, they pass the ball 76% of the time, which is 24% higher than any other grouping of these 2 players on or off the field. When both of these tight ends are off the field, the Falcons run 30%, or the Falcons pass 30% of the time. They only run 30, they run 70% of the time when both of these athletic tight ends are off the field. They have a negative 25.3 pass rate over expected when both of these tight ends are off the field. When both are on the field, they have a 76.1% pass rate. So again, this type of code can be applied to any team for any player. You don't even need to do both players. You could I kind of have in my code, you can see I kind of do this for Sam Laporta, which is a singular player, right? So you can run the same code. I just copied this from my GitHub, but you can feel free to ignore this, but you can do this for a singular player. And look, when Sam Laporta is not on the field, the Lions pass 41.1% of the time. When he's on the field, they pass 61% of the time. That's a 20% difference. Like that is a little bit meaningful. It's not like it's a complete tell for run or pass, but in terms of splits, I think that is meaningful for a singular player. And again, there are players like this, as we showed in the first code we wrote in this tutorial. There are certain players where even when we're factoring in first and second, only looking at first and second down, when they're on the field, it's a pass tell or a run tell. So again, that was just something I showed. You can apply it to any team, any player that you want. So the next thing I want to talk about, it's basically, we're going to take this code. So I'm going to delete or just redo a lot of this because we're going to go back to the Bills example. But again, one of the things that I've learned in my experience is there's a lot of things that coaches want to control for. Namely, they want to, they really only like first and second down. And in the third downs, they like to do their own thing because, third and longs, they dial up their stunts, their pressures, their simulated pressures, their blitzes. So let's factor in, let's do the same exact thing, but let's only look at first and second down just so we're controlling for kind of like neutral game script situations. So if we do the same thing, we're pretty much getting the same result. The Bills pass the most when Dalton Kincaid is in the game. Now, what are other kind of confounding factors we can think of that could potentially play into a team having a high or low pass rate? Well, to me, one is always going to be where they are on the field, right? In goal line situations, most teams run the ball more than they pass. And so that could be skewing the data as well. So one of the things you could also do, you could look at plays where the offense is outside of the red zone in general, which is when you do yard line 100 is greater than or equal to 20. I like to do greater than or equal to 13 14, because I think I've read this from people like people like Cody Alexander and stuff in the past. 14 or the plus 14 to the plus 5 is the low red zone. Plus 4 to the plus 1 is the goal line. So we want to filter out those situations just in case that's skewing any of the numbers. And if we check, again, it doesn't really make that much of a difference. But again, everything is about adding context. You're obviously shrinking the sample size down as well, which, given that we only have 11 weeks of data, that's not great. It's not ideal, but there are certain things that I've learned in my time that coaches like to see. And on my scouting app, that's in my pin tweet, I do a lot of filtering out of situations because I want to create as many neutral game situations as possible. So only looking at first and second down, only looking at non-red zone plays. I think that definitely helps. And it just helps to add more context to whatever we're doing. Okay. So now let's create something with this. What can we do with this that you can send to a coach? If you know anyone that works for the Buffalo Bills, you can send them a table that we're going to put together in this tutorial, and in preparation of helping them self-scout themselves and making them less predictable as an offense. So we're going to create, for the first time, a new data frame called Buffalo Run Pass. We're going to take data from the play-by-play data set, use the pipe function there. And again, just like this, you honestly can just copy this and do it. If you want to build that muscle memory and type it all out, that works as well. So we're going to look at first and second down. For the sake of this, just because I don't want to lose too many snaps, we're going to take out the non-red. We are going to include red zone plays. So we're looking at first and second down, non-garbage time situations for the Buffalo offense. We're also going to filter the position, just like we did last time, to halfbacks, receivers, tight ends, and fullbacks. We are going to group by full name, position, and pause team. And just like we did last time, or we're going to change up the names a little bit just for the table, but we're going to do snaps played equals N. So N is basically saying how many rows of the data are there with this player on the field. We're also going to do pass rate equals mean pass, filter out NAs using the na.rm equals T function. We're going to look at rush rate, which is mean rush. Same thing, filter out any NAs, which shouldn't be the case because we are looking at only running and passing plays. And just like before, we're going to do pass rate over expected equals mean pass OE. And to make the table, we want to make it look pretty, right? Like we want this to stand out. We want this to look really nice. So we're going to left join it with a data frame called, okay, actually, so if you go back up here real quick, I'm sorry. Also, I would load in this NFL Fast Star package. And if you don't have that installed, just install it up here. Again, I'm sorry for the inconvenience here, first time doing something like this. So yeah, install it first, then read it into the library. And so we come back down here and we're going to do a left join with team logos colors. And we're only going to take the team abbreviation and the team word mark from this team logos colors function. And we're going to left join it when the pause team equals the team abbreviation. Boom. So now if we open this, what do we get? We get every player on Buffalo with their position, with the amount of snaps they played, the pass rate when they're on the field, the rush rate when they're on the field, which is 1 minus the pass rate, and then the pass rate over expected. Just off the bat, when Deontay Hardy's on the field in general, or just on first and second downs, the Bills have a 76% pass rate. When Quinton Morris is on the field, the Bills only have a 40% pass rate. And then again, to contextualize that, they have a negative 12.9 pass rate over expected. Another thing I would do for the table that we're about to make, for pass rate over expected, do the mean, and then outside of the closing parentheses divided by 100. And you'll see why I did that in a minute. All right, let's make a table. Let's make something pretty. Let's make something that we can send to Sean McDermott, to Joe Brady, for them to do their self-scout. So we're going to take the Buffalo run pass column, and we're going to arrange the table first off in the way that we want all of the columns to be lined up. So we're going to say the player's name is going to be the first column. We're going to say the position is the second column. We want the team word mark as the third column. And then we'll just add all of the stats that we included. So snaps played, pass rate, rush rate, and then pass rate over expected. We're going to do this a little ungroup function because anytime you do a GT table, make sure you use the ungroup function. It's one of the most annoying things I think I've ever learned, but it's just something you have to do. And then we're going to range it by negative snaps played, just so we have the players who played the most at the top. And we're just going to start off with this. Okay, so what do we have? We have a table that is arranged by the number of snaps played. We have the pass rate, we have the rush rate, we have the pass rate over expected. Well, this looks nice, right? It is a table. It is something that if we take a screenshot of this or a picture of it, we could send it. But what is this? What is this? And what is this, right? Like, we don't want all these decimals. We want it to look much nicer than it is right now. So from here, there are a bunch of things to GT tables that we can do to make it look really nice. The first thing, we want to turn this, team word mark, we want to turn the website or the link into something. So we're going to use the GT IMG, which stands for image rows, and we are going to say team word mark. And let's just run it and see what happens. Boom. Now we can see this turns into the Bills team word mark. So that looks much nicer. That looks much nicer. The next thing, we want to turn these into a percent. We want to make it look nice. Like, we want coaches to not have to look through 7 decimals. So we're going to do FMT percent, which is from the GT package. We're going to do columns equals C, because we're going to have to reference multiple columns here. Pass rate, rush rate, and pass rate over expected. And we only want 2 decimals to show up here. Boom. Okay, now what are we looking at? Oh, look at that. Much nicer. This is like an actual percentage that we can, see and kind of visualize, right? And same thing for pass rate over expected. The Bills pass 6% over expected when Gabe Davis is on the field. Okay, now what else can we do? Well, we want to make it look nicer. So we're going to use this opt align table header function, and we want everything to be centered. We don't want it. So we want everything to be, align equals center. So what that does basically is just puts everything in the middle. We want all the data to be aligned in the middle. The other thing we want to do, we want to align the column name. So we're going to do cols align center. And you can see everything is centered, just like, an Excel sheet. Everything is centered. It condenses everything as well, which looks really nice. The next thing we want to do, if you're making this table and you're sending it to the Bills, you should get credit for this. You want them to know it came from you. So we're going to use this tab source note, and we're going to say table is made by Arjun Menon. Feel free to, insert your own name. I like using this to separate it. And then you can do, if you're going to post it to Twitter, I always like to reference the data where it comes from to give thanks to the people like Ben Baldwin, Sebastian Carl, Tian Ho, John Edwards, anyone else from the NFL Radar family. And we're going to say the data comes from NFL Radar. Okay. And what does that do? That just puts it at the bottom of the table. Again, just gives you credit. It gives the NFL Radar team credit for everything that's being put together. And then we want to change the titles of each of the columns, because we don't want these underscores for any of them. So we're just going to rename everything. So we're going to rename full name to player. Let's rename position can stay as it is. Team word mark. You can just say it's team, or I guess let's do offense, make it more professional. We can rename snaps played to snaps, pass rate to pass rate, but separated by space. Same thing for rush rate, which is separated by space. And then pass rate over expected, just do pass rate over expected. Run that, and we can see, again, just continuing to get much nicer, looks better there. And then we can also I like to add this as well, which is opt row striping. And then also let's add a title, because the title is important. It tells the person or people, whoever you're sending this to or whoever's looking at it, what they're looking at. So we're doing tab header, title equals Bills run pass rate by player in 2023. So you can see the opt row striping just adds a stripe or a line between the top or between the title and the rest of the data, adds a stripe between the last line and our caption at the bottom. And the last thing we want to do, we want to add a theme. So I like using 538. You can see it just like makes it look a lot nicer. 538 always has the best themes. You can also play around with this. My other favorite, I like using the ESPN one. This one also looks pretty clean. You can play around with it. PFF even has a theme. This is just like a PFF table that you see Nathan Yonke post every single Sunday or Saturday, or yeah, Sunday, Thursday, or whatever. The New York Times. This one's also kind of nice. I just think it's sometimes hard to see the column name. So again, for this, I'm gonna go with my go-to, which is the GT theme 538, and boom. So you can take a screenshot of this however you want to, but you could also formally save it in this way. So what we're gonna do, we're gonna go back to the top and we're gonna do buff table, and then we're gonna read all of this code into this buff table object, which is a GT table, and then we're gonna use this function GT save, and we're gonna do buff table and just save it as whatever you want it. Buff run pass table.png. So if you run that, it should save it to whatever folder you're in. You can see here. So it did save. So I go to my files and I go to the folder that I'm running all this code in, the MFANS coding tutorial. This is the directory. You can see that it has the buff run pass table. I can open it. You probably won't be able to see it since it's on my screen, but if you click on it, it should open and you should see whatever table that you had here, and it comes in a PNG. So you can post it to Twitter, you can post it online, you can write about it, do whatever you need to do. And again, all of this code you can apply to any team for any player. You can adjust the win probability settings to look at different garbage time. You can look at, different downs. Again, this code up here, which is down and distance, you can play around with that if you want. In future tutorials that I hope to continue to make, if people enjoy this one, just continue to break things down by down and distance, by a bunch of other factors, which I think will be super cool. Another thing I'll point out that you can do instead of win probability, if you're not a big win probability fan, you can also do score differential. So we can do the absolute value of the score differential. So if the offense is winning or losing by, let's say, 3 touchdowns or 2 touchdowns, or say 17 points. So if we do this, we can see these are all plays where the offense is winning or losing by less than 17 points. But again, that's completely up to you. I know people have different preferences, but this is something, again, I think using win probabilities is smart for the long run, and it kind of shows more of like an analytical side to things that I think will be helpful for people in the future. All right, so that was the 2023 coding tutorial number 1. If you have any questions, don't feel shy to hit me up on Twitter at ArjunMenon100, which is where this tutorial will be posted first, and my GitHub at ArjunMenon10. You can find the code that I wrote on this video there. And so you can make sure to reference that and copy paste it. Again, I would recommend writing all this code out. It helps with your muscle memory. It helps you to learn to code faster, in my opinion, and just to work with the data that we have at hand. But I want to thank everyone for watching this video and hope people were able to take things away from it. If you have any feedback, again, don't feel shy to leave a comment or hit me up on Twitter at ArjunMenon100. But hope everyone has a happy Thanksgiving, again, since I'm recording this 2 days before Thanksgiving. Happy Thanksgiving to all. Happy holidays. And until next time, go blue.